Today, today we are going to discuss about the RFC communication types. There is a RFC connection types. How many types of RFC connections we have? Where can we create? What is the transaction code to create the RFC connections?
SM59s.
What are the types of? What are the how many ways like connection types? If you go to SM59, if you go to the SM59, you will see there are the RFC connection types. There are the types of RFC connection types here. So above connections, connection to the external server, internal connections, then logical connections, TCP/IP connections. So there the types of connections are there here. There are the types of connections are there here in the systems. These are the connection types, right? So these are the connection types here, right? So that is the answer I'm expecting from everyone. These are the connection types in SM59. This is one of the question they may ask you. So if you don't answer during the when I ask the questions, that will be difficult for you. So once again, I am telling, if I ask any questions, please try to answer. Okay. So these are the RFC connection types. The same time, we have the RFC communication types. RFC communication types. There are the four types of RFC communication types here. One is the synchronous RFC here. Synchronous RFC. So one is the synchronous RFC here. There are the four types of communication types here. One is the synchronous RFC here, right? The second one is the asynchronous RFC here. Asynchronous RFC here. Async. The third one is the transactional RFC here. Transactional. So transactional RFC. The fourth one is called the queued RFC. Queued RFC here, right? So queued RFC here. There are the so queued RFC. There are the so four types of RFC connections we have in types of communication types here. There are the four types of communication types here. So what does it mean by communication types? So sub communication type means both the systems, source system, target system. So source will send the data to the target, then target will receive it, then it will store it here. Then this is the sending the data from one system to another system, sending the data from source to target. Suppose like sender to receiver or sender. This is the sender. So this is the receiver system, or this is the source system. This is the target system here. Source and target receiver here. There are so two types of connection types, communication types here. So normally connection, why we will use the RFC communication, RFC connections to transfer the data from one system to another system, right? To transfer the data from one system to another system, we will use the RFC connections, right? So here, there the types of RFC connections are there here to transfer the data to the here. So one is the synchronous way. Synchronous way, we can send the data. Synchronous way, we can send the data here. Synchronous means both the systems should be available at the same time. Sender and receiver, both the systems should be available here. Here, so here the calling program. Here the sender will call the one program that will be executed in the receiver. Then receiver send the acknowledgement back to the sender saying that I received the data. Something like that called the synchronous. Synchronous means both the systems like sender systems and remote systems both are available at the same time, must be available at the same time the call is made. When the time of calling, both the systems must be available. Then so in the sender will send the data to sender will send the data to the sender will send the data to the receiver. Then receiver will receive the data. Then it will send the acknowledgement back to the it will send the acknowledgement back to the so sender saying that I received the transaction, send the one more transaction. Then it will send the one more transaction. Receiver send the acknowledgement, send the transaction, receiver send the acknowledgement saying that I received it here. That is called the So synchronous RFC, it required the acknowledgement from the, receiver to source. So means sender. So receiver will send the acknowledgement to sender. Sender will initiate the one more data. Then it will send the acknowledgement as soon as it receives the transaction. That is called the synchronous RFC. That is called the synchronous RFC here. Then asynchronous RFC. This type of RFC communication, this type of RFC communication is, so here, source will be executed in the targets, even though target is not available. So means it does not wait for the acknowledgement here. So synchronous means it will wait for the acknowledgement. The asynchronous mode, it does not wait for the acknowledgement whether receiver will receive or not. It don't bother. When sender will, in the isolation mode, it will send the data to the request is processing step is executed in the remote system in the isolation mode. If the remote system is cannot be reached at the same time of the call, asynchronous calls are, asynchronous RFC calls are lost. Asynchronous RFC calls are, client calls are, will be lost. So this is the difference between the synchronous, asynchronous. Synchronous, it will wait for the acknowledgement. Asynchronous, it does not wait for the acknowledgement to be sent it to the primary, means sender here. This is the synchronous, asynchronous RFC, just a theoretical parts, right? Next one is the transactional RFC. Transactional RFC here. So this type of RFC connection is similar to the asynchronous RFC, but it will allocate the one transaction ID to the each and everything. It will assign the one transaction ID. So in this way, it will guarantee that the request is sent to the several times because of network problems, or it is processed only once, right? So means whenever it is sending the data to the target, it will assign the one transaction ID so that there is no duplicates here. So one order wise, it will process the transactions here. Transactional RFC means it will assign the one transaction ID. It will assign the transaction ID to the your call, transaction ID to the data. So it guarantees that if a request is sent to several times because of the if any network problems, the request is going to the multiple times, but the receiver will process only one time here. Why? Because only once it is processed only once, like here. So unlike in the asynchronous RFC, the transactional RFC does not both the side like does not like receiver should be available at the same time. It should be down also. It will escape the one transaction ID. As soon as receiver is available, it will flow. It will send the data to the your respective target system here. Target receiver, it will send that. So meanwhile, data is on failed status on the source system until target system is available here. Target system is available here. It will keep on checking. It will keep on checking the whether source receiver is available or not. Then it will allocate the one transaction ID. Then it will send it here. So where can we check whether transactions are flowing correctly or not here? In SM58 is the transaction code. SM58 is the transactional RFC. Here we can see the status of the transactional RFCs. Status of transactional RFCs in SAP level here. If we go to the SM58 is the transaction code here. Here, just check if for today for any transactional RFC is failed or not. Nothing is failed. Just check the previous days here. Anything is failed or not. Yes, I see the basis related some workflow related transactional IDs are failed here. Some transactional RFCs are failed here. Transactional RFCs are failed here. So these are the some data which is sending to the target system is the, so this is the target system here. Workflow is the one of the RFC destination. It is transferring the data to the workflow here. It is transferring the data to the workflow here. It is transferring the data to the workflow here. That is the transactional target system here. So it is sending to the target system via SM58. So there is a transaction ID assigned. You can see the transaction ID. The serial wise, the ID will be assigned by the system. The serial wise, the ID, the transactional ID is assigned. The serial wise, the transactional ID assigned to the system here. You can see the serial wise, the transactions are assigned here. So there is no duplicates here. If the data is sending to the target system, there is no duplicates. So duplicates are not allowed here. Duplicates are not allowed here. So in this way, the transactions are going to the one system to another system here. What is the target? So same system or different system also we can send the transactions here. So in SM58, we can see the transactions, the failed transactions, and so all those information we can see it here in the system here, right? Through RFC destination, the data will go to the respective target system here. So transactional array means it's kind of asynchronous, but it will assign the one transaction ID in source system. In the source, it will assign the one transaction ID. This is called the transaction ID. Then the user, so it will say like user is locked. If the user is locked, means target system is having some error, user is locked. So then whenever user is unlocked, whenever we reprocess, all the data will be processed to the respective system here. That's what's the so we can say it like a transactional RFC. In SM58, it will assign the one transaction ID to the your request, your data. Then after that, it will send the data. It's not like that. Source and target should be available at the same time. It's not like that here. Even though target down also, it will keep the data in the hold. As soon as target system is available, as soon as your target system is available, then it will send the data. But synchronous RFC, at the same time, if both the systems should be available, then only it will transfer the data to the receiver here. But asynchronous RFC, so in the transactional RFC, it's not like that here. Okay, that is the transactional RFC here. The next one is called the queued RFC. Queued RFC. The communication, this RFC communication is the extension to the transactional RFC. The queued RFC is the extension to the transactional RFC, the before one. In this method, all requests are queued up. Inbound queue and outbound queue are processed in a sequence. So are processed in a sequence here. So why? Because sequence wise, queue wise, in order wise, it will send the data here. So in this method, guarantee that requests are processed in a sequence which are received by the target system here, right? Suppose queues wise, it will send the data to the respective system here. So queues wise, so it will send. Suppose like example, there are the multiple systems here, right? Multiple systems here. So queue wise, it will transfer the data. Queue means in order wise, it will transfer the data to the in this queue, and order wise, it will transfer the data to the in this queue. Otherwise, it will transfer the data to the in this queue. Like that, order wise, so in the queue format, the line wise, it will send the data to the respective target system here. Respective target system here. The queues, where can we create the queues then here? So the queues creation in the queued RFC, we can register the queues in SMQR, then SMQS, SMQR and SMQS, we can register the queues here, right? We go to the SMQR. Here we can check the inbound queues which are coming inside of the system here. So which are coming inside of the system. These all are the inbound queues, standard inbound queues here. These all are the inbound queues. These all are the inbound queues which are coming inside of the system here, right? R means register, active status here. Unregistered means U means unregistered. So which means the queues are unregistered here. Queues are unregistered here. So this is the way we can say the queues are active. So we can create the queues also here. Just go to the registration, then just queue name, suppose like, so ZZ star, something like that. You can set it. Just click on the OK button. The queue will be registered here. The queues will be registered in this case here, ZZ. So the queue will be registered here. So why? Because in the ZZ format, the queues will go to the respective target system here. That is called the SMQ or inbound queues. Inbound queues creation, inbound queues here. Then SMQS is called the outbound queues, outbound, which are going out, which are going outside of the system. Then SMQS is the outbound queues here, which are going outside of the system means so based upon the RFC destination, which will go out. So, so here we can based upon the queues, based upon the RFC destination, based upon the RFC destination, data will go out to the system here. Here we can see in which destination this is going to be. This is which destination. In which destination this is going to the respective target system here, right? So that is the one thing here, we can say it here, in which destination that is going to the target system here. So here we can point out the which systems and all those things, we can see it here, which destination here, right? So then in ECD also we can check the RFC connections are working or not here. So here the scheduler will send the data to the schedulers. The scheduler will send the data to the from respective systems here. The queues wise, in order wise, it will send the data here to the respective system here. Suppose this is the source system here. This is the target system here. Source and target system here. Source and target system here. So source is the ECC, target is the BW system here. So in order wise, it will send the queues. So queued RFC means queues means order wise, through queues it will send the data to respective system here. Suppose example ECC on order wise it will send the data to the respective queue here. So suppose like BW star queue. CRM system it will send the CRM CAF queues. So some other queues, order wise, line wise, it will send the data to the respective system here. So all the data not in the one RFC destination, so it will go, but it's order wise, it will point to the one RFC destination, it will go to the respective target system here through queues. So queues means normally in our schooling days, we have the queues, right? First class students in one batch, one queue, second, third, fourth, in the prayer, during the prayer, we will form a one line, right? First batch, first class, second class, third class. So why in the queue wise, why we are forming a batch? Why? Because for identification purpose, one order perspective. So without any disturbance, without anything, so we are forming a queue and we are sending, we are moving to our classrooms and everything, right? Same as like here also from source to target. So sequence wise, order wise, the data will be moved to the respective system here. So if you don't have the queues, what will happen? Via this destination, whatever the any data will go to the respective receiver system. But where it will set, there is no order here, right? But in the queued RFC, there is a order will be followed here. The sequence wise, the order will be followed in the queued RFC. The order will be followed in the queued RFC here. That is the one thing called the queued RFC. Okay, that is one thing in the queued RFC here. So in SMQR, SMQS, we can configure the queues, inbound queues and outbound queues also. Outbound queues also. Outbound queues also we can configure it. Inbound queues and outbound queues we can configure it here. Inbound queues and outbound queues we can configure it. So through these queues, the data will go to the outbound means which are going out. Inbound means, outbound means, I will tell you. This is the one system. This is the another system. So for each system, coming in, coming out, coming in, coming out. Okay. This is the inbound. This is the outbound here. This is the inbound here, right? So this is the outbound here. So what will happen here? So the data, this is the data. So data is there in the within the system here. Some transaction happened here. then it will go to the outbound. RF bound means RFC destination, definitely, which is pointing to the one system here. So here there is a one inbound which is coming inside of the system, inside of this system. So this is the inbound. Here data will come and store it. Then if you add on it record added, then it will go to the outbound again. Then it will go to the outbound again. Then you will get it like again the inbound. Again you will get the inbound to the this system here. Again you will get the inbound. So system in which is coming inside of the system, outbound which are going outside of the system, right? Inbound and outbound here. So for outbound and inbound queues registration, we can do it in the SMQ or SMQS, queues creation, all those things we can do it. If you don't have the queues, data will not be moved, data will not be so processed to the respective target system here. Data will not be processed to the respective target system here, right? So here, where can we check whether data successfully failing or successfully going or not? Where can we check here, right? So there is a transaction codes called the SMQ1 and SMQ2 here. So QRQS is for the queues registration, queues creation and registration here. Then if you go to the SMQ1 here, you just click on the enter button. Here we can monitor the outbound queues here, SMQ1, outbound queues. In SMQ1, we can check the whether the data is going to the respective system or not. We can check it out in the system here, outbound queues here. Then inbound queues means SMQ2, Q1 and Q2 here, SMQ2 here, SMQ2 here. So just check here in SMQ2, are there any data locked? So nothing is there here. So nothing is failure, 0, 0. If anything found, what is the queue entry? Then how many entries are failed and each and every queue here. So if the queue is locked, then we have to go to the respective queue registration, queue inbound queue registration. Then we have to register. We have to register the system here. We have to register it here. Instead of D, then we can make it as the R. Instead of D, mode type connections, we can check it out here. Then just check the connection. R means active status registration here. U means inactive status here. The queue is not active, which is inactive. Which queue is inactive means then the data will fail. The data will fail here. The data will fail here. That is the inbound queues and outbound queues are available here, right? So SMQ1, SMQ2, outbound queues and inbound queues here, right? So here the queues creation and everything we can do it in the QR and QS. To checking the status of the entries, how much data failed, all those things we can check it in the SMQ1 and SMQ2. We can check all this information, we can check it out. We can get the all the information, we can check it out here. That is the gallery SMQ1 and SMQ2. This all are comes under the queued RFC. Now it is comes under the queued RFC here. Okay, so that is the queues RFC communication types. Here synchronous RFC, asynchronous RFC. Just in theoretically we can discuss, but transactional RFC SM58 is the transactions to check the whether any transactional RFCs are failing or not here. As a day-to-day basis consultant, we need to check the any transactional RFCs are failing. Then we have to create a ticket and we have to work on it here. Okay, we have to work on it here. So then that is the transactional RFC. Queued RFC means Q1 and Q2. Queues registration, queues are QS low. We can configure the queues registration and everything. We can do that one here. Okay, that is the queues and the RFCs here. All right. So any questions, anyone? Is it clear?
Certain companies like which RFC communication type they prefer? Like, is that the third one, transactional RFC?
They have each company, they have the transactional RFCs and queued RFCs are there. So
Okay.
it depends upon the scenario. They will use the transactional RFCs and queued RFCs here. They will use it here.
All
Transactional RFC means SM58, queued RFC means Q1 and Q2. It depends.
Okay. So they do not prefer the synchronous and asynchronous type, right?
Right, right.
Okay.
Those are the normal procedure actually. Normally it will happens. So normally it will happens in SM59 here. So, but allocation of the transactional ID queues, these are the transactions. These are the, so normally they don't prefer, normally they will use the synchronous RFC only, or sometimes they will use the asynchronous RFC also. So it will generally, it will, system will use as here, it depends upon the system. So there is no transaction codes here, synchronous, asynchronous. But transactional RFC, queued RFC, we have the transactional code. But sync, async, we don't have any transactional code, which means, so basically internal mechanism, these are the internal mechanism, it will happen when the time of, so calling to target remote calling program or called program, it will happen automatically.
All right, sir. All right, sir. And sir,
So
basically
yeah,
we might be in need of checking these queues. Just I'm giving a thought process to it when we are doing the transport activities in that phase, right? Mostly.
right. No,
Okay.
yeah. So transport activities are sending the data, IDOCs processing. So that time, so we will use all those things here.
Okay.
Okay. So that is the one. So the next one, which I'm going to discuss about the some other transaction codes are called the, so we have SOST, we discussed. What other things we have discussed? Queues we discussed. Okay. So some other general transaction codes called the SWU3. SWU3, automatic workflow customization here. Workflows here. Workflow customization here. Workflow management here. So this is the workflow management here, workflow management here. So here, this should be the active status here. This should be the active status here. Always this should be the active status here. So that the data will be processed here. Workflow means some approval procedure, some task. So if anyone raises the any purchase order, it is the below 1 lakh, one approval, above 1 lakh, one more approval, above 10 lakhs, one more approval, like that, how we have the workflow concept. So that time, the workflow activation we have to perform in the SWU3. Just remember that word, workflow activation we have to perform in the SWU3. SWU3 is the transaction code where we can perform the, so this transaction code here, where we can perform the, so these things here, just to checking the workflow either active or not. It's not the regular one. In case someone asks you what is the transaction code for the workflow customization means, so this is the transaction code. Okay, the tasks will be executed, the flows will be executed, the workflows will be executed. In this case here, workflow customization here, right? So yeah, apart from that, so SMICM, SICF that we discussed with Scott, SMTP, so that we discussed yesterday, SOST, SOIN, so those things we discussed, and some other performance related transaction codes here. Okay, SAP performance related transaction codes here. So